Ah, Joe Nuri ne. Eh? Dai wala. Na san ke kan. Ai na. Baka ko da ko sama. Na wani group. Ai, da ka da. Ida mu ko ta.
Hello, good morning, and welcome to T5. Let's allow a few more minutes for the other guys to join. Thank you. If you're just joining, welcome. We just allow 3 more minutes and then we can get started. Welcome. If you're just joining, welcome. We will start in exactly 2 minutes. We will start in exactly 2 minutes or 1 minute now. All right. Welcome again to T5. And I will just do a quick recap of what we discussed last week. I'm just going to do a quick check to see how many persons submitted the assignment. As of yesterday, only about, let's say, 9 people. Only about 9 people submitted the form. So that's quite a very, very low number. But I'm going to do a quick check now and see if we have, more submissions. I doubt. Just know that if you did not do this, again, there will be some consequences to that. But for those that did, kudos to you. Okay, I see 20 responses. There was duplicate submission by a few people. I think 1 or 2 persons made duplicate submission. At a first glance, it would seem like some of the responses were just copy paste from ChatGPT. Good effort, but not really cool. It doesn't really show that effort we have put in. But I'm just going to give you some response on that. So before I respond to that assignment, last week we talked about cover crops and also crop rotation with emphasis on chili pepper. And we identified at least 4 factors that could be used to determine what cover crop to use. If the cover crop uses a lot of water compared to the main crop, if it requires sunlight exposure for a prolonged period, if it's a nutrient scavenger, or if it's a nutrient fixer, etc. So in the process, we drew up a few examples of cover crops that can go with chili, which I will come back to in a minute. Then I gave us this assignment to look at and come back and submit on the link provided. Like very few persons submitted. So you still, maybe there is no time to submit again. But let me tell you what's happening here and what I expected to see in the response. Now you will see that this particular crop rotation plan is rotating between primarily sweet corn here, onion here, tomato here, and also following here, right? So it's rotating between sweet corn, onion, some lettuce as well, because you have this thing in the fall that is not the same as this. So it has sweet corn, onion, some lettuce, tomato. That's a rotation plan. Then fallow in some cases. So this is more or less a 4 or 5 year crop rotation plan. And the reason why, for example, lettuce was introduced at this point was to kind of optimize nutrient use and uptake. The other reason why, I would say the other objective why this crop rotation plan was designed uh, was also for improving not just soil structure, but also preventing erosion. So you will see a lot of scavenging crops, like the spinach, the rye as well. So crops like spinach and rye are likely, included because of their role to scavenge nutrients. They go deep in terms of their roots and also provide cover for the soil. So you see, it prevents the cover crops, or the cover for these crops prevents erosion. And while the scavenging roots, I said the roots or the scavenging crops, they have like deep roots. So they go deep down to kind of look for nutrients and water. So in the process, they improve the soil structure. So that's the reason why the second objective uh, for this crop rotation plan. The third one, which maybe not so common, in our culture, is the bucket wheat. Bucket wheat is a nitrogen fixing plant, particularly sorry, is it not a nitrogen fixing? It's a phosphorus fixing plant. So while the likes of legumes, which does fix nitrogen. So you see three things that happen here. One is diversity. The diversity of crop optimizes nutrient use and uptake. The cover crops provides soil improvement. So the cover crop, the scavenging cover crop provides soil health improvement, while the bucket with fixes nutrients. So this person is trying to, in the long term, use less nitrogen while maintaining or even improving his result. Of course, we can tell that this person is primarily a vegetable farmer. The sweet corn is a secondary crop in this case. Now, when it comes to water use and sunlight, you would notice that zucchini was introduced in the second rotation. Is it second rotation? First rotation and second rotation. Zucchini, uh, first and third. Zucchini and tomato. Now, if you recall from last time where we mentioned, somebody mentioned watermelon. Was it watermelon or cucumber? And I said that these are really high water use crops. And then the plan also introduced onion and lettuce, which have moderate uh, water use. Now you would notice that when zucchini and tomato are being grown, the onion and lettuce is not grown, because if you grow zucchini and onion together, the zucchini or tomato will compete for water with the onion, thereby making the onion suffer in the process. They're very, very strong water use crops. So in summary, this plan is designed to balance resource use. So, water use, preserve the soil fertility, etc. Now, the question that came to my mind is, and I was thinking somebody was going to notice, is how do you improve this crop rotation plan? Because obviously nothing is perfect. So if you were to improve it, what would you change? Does anyone want to quickly respond to that before I say my own opinion, my own thoughts? What would you improve in this crop rotation plan? Okay, you can raise your hand and I will stop talking whenever you raise your hand. I think I will introduce more legumes in this plan because they will fix more nitrogen in the soil and reduce the need for fertilizer long term. that is very much lacking in this plan. Okay, the question is, what would you do to improve this crop rotation plan? That was the question. And I'm saying the first thing I noticed straight out of the park is there is inadequate leguminous crop in this plan. So that means this person already made up their mind to use a lot of fertilizer. Now, if you were a smallholder farmer like many smallholder farmers on the continent, in Nigeria included, you know that fertilizer is quite expensive. So any crop rotation plan in Nigeria should introduce more leguminous crop because overall it will reduce your dependency on uh, fertilizer, on synthetic fertilizer. The second thing I would also do is to rotate. So year by year, I'm going to rotate between a shallow rooted crop like corn and a deep rooted crop like carrot. So I'm going to be alternating between a corn and carrot. Reason being that with carrots, for example, carrots are scavenging crop, they have deep roots. They're going to improve my soil and other microbial activity ahead of the next year when I'm going to grow a shallow crop. So they're going to be like complementing each other and reducing compaction. The third thing I would also, maybe not so obvious, is to extend the fallow, to have it fallow for a much more longer period of time. But I would say for smallholder farming, this might not be an option because you have economic need every year. And perhaps I might also introduce disease and pest resistant or even drought resistant crops variety. That would be the only three things I would change in this plan. So the other thing that I also thought about while looking at this is what is the single most important choice to make in a crop rotation plan like this? I think the obvious answer, based on what we discussed last time, with respect to climate change, is to have cover crops. You know, in each of this rotation plan, in each year, have a cover crop as part of your growing growing plan. So you don't have to wait for a year before you grow cover crops. You can actually integrate it as a part and parcel. So that's exactly what is happening. And we were supposed to, as a second assignment, you know, develop a crop rotation plan for chili. Okay, you know what? In the interest of those that didn't do the assignment, I'm going to skip talking about this, and I'm going to have you, based on what I've explained so far in terms of designing a crop rotation plan, we're going to redo number 2. Literally everyone did not do a good job from the submission so far, so you have a chance at redemption. So let me jump into today's topic. Any question? Any comment? Okay. Just raise your hand at any point, and I will stop and have your questions taken. So today we're going to be talking about 4 tools when it comes to precision farming for climate smart practices. The emphasis here is, you know, making sure that farms or farmers are insured against any climate disaster. It could be rising temperature, it could be drought, it could be flooding, whatever. So these are the 4 things we're going to look at today. The first one is, you know, grid-based soil sampling. I'm going to show some examples, and we're going to do some practicals at the end of this chat. So the thing I wanted to take out of here from this whole slide is we're talking about soil testing, right? Now, before you do soil testing, you would have to collect samples of the soil and take them to the lab for analysis, right? So let me drop a small poll. How many of us here are as soil scientists. Let me drop this little poll here. Either you are studying or you've studied soil science or soil related course. So I just dropped the poll. I want to see how many of us are soil scientists. If you look at the activity section, you will see the poll. I want to see your response. Soil scientist. Okay, one person said no. Yeah. So, so in soil science, I think we don't have anyone. It looks like it. So in soil science, what we try to do is identify first the content of that soil. So what is in the soil? Then the second thing we want to do in soil analysis or soil testing is to evaluate or to know how much nutrient is available in that soil. So remember, for any crop to make that bountiful harvest that you are looking for, that crop or that seed that was sown requires a few things. One of them is micro and macronutrients in the soil. The second one is sunlight. So if there is no sun whatsoever, no crop can make food, period. So sunlight is required for food to be made. The third one is water. Talk about water a little bit because water is how this nutrient is transported into the plant so it can now technically react with the sun to make food. So it's a kind of ballpark process that happens. So soil is a very integral part of production, and sadly, many farmers don't do soil testing. And I want us to, at the end of this, I want to present you with a tool that you can use to drive more farmer participation in soil testing. From the research we've done so far, we found out that it costs a lot to make soil testing, but most importantly is that the time it takes to get the result, we do not have enough lab to serve everybody. So in order to collect soil sample, if any one of you, surprisingly nobody here is doing soil science, there are many ways that people collect soil sample. Some use grid, so they divide the farm into like 4 parts and take a sample in each part for testing. Some persons do fixed point, which is very common in Nigeria. They draw an X on the farm and take samples from each corner of the X, etc. But I think one of the things that we have found so far is that these methods, even though they may work for flat lands, if a land is not so flat, and which is a lot of lands are not so flat, you might fall into the trouble of sampling error. So let's look at these two maps here. Please just stay with me. I'm going somewhere with this. I know it's a little bit technical, but you will see where I'm going with this. This is the same farm. Both of them are the same farm, but two different imagery of the farm. Here you're going to see the elevation map. And I'm going to try to zoom in a little bit here so you see, so you will see the legend. So what the legend says here is that the dark color is, okay, you see what's happening here, right? It says minus 314, and here it says minus 303. So what this means is that this particular farm is actually below sea level, you know, below sea level. You know, when you talk about elevation, there are two ways to look at it. Every point on Earth can either be above sea level or below sea level. So if you're below sea level, you're going to have a negative elevation number. If you are above sea level, you're going to have a positive elevation. So let's use Google, for example, and show you a little bit of example. Now, I understand this is a little bit technical for some of us, but stay with me, okay? So let's say, what is the elevation of Yola? I want you to take note of what I'm doing here, right? So here we have Yola, 599 meters. For those that don't know, elevation is how high a land is above sea level. Okay. So Yola is 599 meters. And let's look at a place like the Abuja. What is elevation for Abuja? Let's use a more specific place in Abuja. Let's say Wali. Uh-oh. FCT. Come on, give me something. Walada. Okay, I think we have something close. It says 70 meters above sea level. Now, what do you notice here? Walada. Roughly 70 meters above sea level. So what you notice here is that Yola is an upland. I mean, Yola is more like a mountain, technically, while Abuja is more like closer, a lowland, is a savanna kind of land. Now let's try and use another place further down south. Let's see Asaba, 55. So what you notice here is that as you move from the north of Nigeria to the south of Nigeria, you are going closer to the sea, isn't it? So Yola, which is at the very north of Nigeria, will have a very high elevation number, which is 500, almost 600 meters above sea level. While Asaba in Delta State, further south, closer to the sea, will have a lower elevation number. All right. So let me show you this on the map so that it can make a little more sense. So if you were in Yola, you are in an upland. And if you were in Asaba, you are the lowland. All right. So what that means is that water will always flow from here all the way to the south and empty itself into the Atlantic Ocean. So elevation is very important, but this is a very big scale understanding of elevation. I know where I'm going with this. I'm going to land just very shortly. All right. So back to our presentation. So there are some places that are below sea level. So basically they exist at, how do I say this? At valleys, such that at the top of that valley is an ocean. And one of such country is in the Middle East, like Jordan. That's where this farm is, one of the farms that we are providing services for. Okay. So from this elevation map, what we see here is that this area is lower than this area, isn't it? Because it's minus 314. Minus 314 is less than minus 303, isn't it? All right. Follow me. I know this is a bit, it's very technical, boys. I'm mathematical, but yeah, you get my point. So what it means is that if I pour water here, that water will likely flow downwards to here, right? Because this is a place of lower elevation, minus 314. This is minus 303. So you notice that if you now compare this map, elevation map, with the soil nutrient map, you notice that, again, here it says 0.22, which is a positive number, so it's lower than 0.51. So it means the green colorations here are places that have more nutrients, while the red is the places that have low nutrient. Remember, these colors are just for illustration purpose, okay? So you notice that the area that is at the lower elevation has a higher concentration of nutrients than the place that is at a higher elevation. So if I decide to divide my farm into 4 places and do grid sampling, collect here, collect here, collect here, collect here, don't you think, and this is a question, don't you think that this sample collection is a bit of a misrepresentation of the nutrient composition in the farm? So if I test the soil, I'm going to have 50% here, 50% here. But in reality, from what we can see here, using the elevation maps as a reference, is that you have more concentration of nutrients here than here. As a result, the result will skew towards this, or maybe skew towards this. If these areas, if this sample collected, it is less concentrated than this. I don't know if you're following me. So what that means is if I'm going to do grid sampling, let's say I want to do soil testing, I'm going to try and divide the farm into, let's call it 8 or even 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will give me a better representation in terms of samples, so that after testing, the result will reflect closer to reality. Okay, I feel like I'm losing you guys, but I'll carry on. So with this kind of imagery, soil sampling becomes a lot more efficient. But this is not what we're talking about. This is not the essence of this T5. I'm going somewhere with this, okay? The real value of knowing the elevation map of a farm, just like we saw in the previous slide, is so that we can generate this map called variable rate map. Now, what is the advantage of this variable rate map? There are two main advantages here. The first one is it can tell you how to vary your seed rate. Seed rate is how much seeds you plant in a certain area of your farm. So for me to optimize my seed that I'm planting, you would notice that if I plant more seed here, guess what will happen? The plant will not perform very well. Do you agree? Why? Because the seeds are going to be competing for scarce nutrients. If we plant more seed in this area, there's already a scarcity of nutrients as a result of what? The elevation. Elevation is now driving as a result of gravity, it's now driving the nutrients downwards. So whatever fertilizer I put here, once I do irrigation or it rains, most of them will wash downwards. So you see, the plants that I grow here are going to struggle. Now, we're going to take this as a kind of example. This coming week, you're going to go out there and try and put this into practice. So when planting, I'm going to plant more seeds around here because this is where I have more fertility. And this is where I can optimize my result and plant fewer seeds here, not like scanty fewer, but much more fewer, all right? Much less fewer than here, all right? The same thing applies with fertilization. If I'm putting fertilizer here, for example, I am most likely wasting that fertilizer because it may not be so efficient, given that this place is already fertile. What I can do is, because I am fighting against nature, gravity, flowing this way, I can now do something like microdosing. Microdosing means putting your fertilizer in small doses per time. One of the best ways to do microdosing is through something called drip irrigation. So I'm going to do drip irrigation around here, so that the fertilizer is supplied to this area in drops, and the crops here can benefit. Because if I just put fertilizer, spray them here, once it rains, most of them will go here. The plant will suffer. But if I'm dropping it bit by bit, they will have the same representation as these people, or maybe not the same, but close. So you see, knowing this map helps you not just optimize how you are planting your seeds, but also how you can optimize, but also optimizing your fertilizer use. Okay. Now there are other kind of variable rate maps, not just for fertilization like we just described. There's the one for spraying. So you don't just take your knapsack and start spraying the whole farm when the whole farm is not sick. You can also generate a, a crop health map that tells you which part of the farm is actually sick. That way you can also save on your chemical use. Likewise with irrigation, if you're doing irrigation farming, you can also generate a water stress map so you can see which area of the farm has more stress on water. Now, if you are spending money on water pumping for the whole farm instead of pumping for just this area of the farm, you see you are saving money as a result. There are lots of use cases, but I guess I am talking too much already. So let me go ahead. So we've seen two tools now that we can use in climate smart precision farming. The first one is the grid sampling if you are into soil testing. The second one is the variable rate maps, which helps you to optimize both spraying, fertilization, planting, irrigation. The third one is something called leaf color chart. I don't know if anyone has seen leaf color chart. Anyone? Okay. So leaf color chart is a very important tool. I'm going to just show you this next slide so you can see how it is used. So let's say you have this thing in your hand, which we would try to provide at least a PDF copy that you can print and use for demonstration. Matter of fact, I'm going to drop this in the chat so that you can have a copy of it in your phone and we can do a little bit of exercise. I'm not very, very happy with the quiet of this class. No question, nothing. Come on, guys. So let me drop this picture. You download it into your phone, and then we'll do a little bit of exercise. So I've currently sent it in the WhatsApp chat. So this is what you are going to do. You are going to download this picture on your phone. It's currently in the WhatsApp chat. Okay. Then I didn't put it in the trainers group. Let me put it there as well, because I see some of us are. So some trainers are here with us. So when you download this on your phone, just open it up on your phone gallery. Then look for any either grass or plant around you. That's if look for any grass randomly. So on that plant, we are looking for a fully developed leaf. So which of the leaf is the biggest one? You select that leaf. Let's see if it's a maize or it's a grass. Look for the leaf that is the biggest, because that's like the most representative of that plant. Then don't pluck out the leaf, because you'll be missing out the whole point, right? So once you have that leaf, now you now place it on top of this leaf color chart that I shared with you. Just place the leaf on top of it. Then make sure that there is no sun. Make sure you are backing the sun. Let's put it that way. So your body provides shades on the leaf, because the sun can provide some kind of discoloration or decoloration. All right. So you take your phone and you put the leaf on top of the leaf color chart. You start from one end and then you slide it to the other end. You're looking for which color on that chart matches the color of the leaf you are holding. Okay. So when you find the color that matches the color of the leaf that you are checking, just note the number and then come back. Let's talk. It's gonna either be a number 2 or number 3 or number 4 or number 5. For your information, leaf color chart can have more than 4 colors. Okay, so you can have up to 6, 7, 8. But check around you for a grass or a plant. Make sure you're back in the sun. Then put one of the biggest leaf on this chart on your phone. Actually, your phone can serve as a as a leaf color chart. Then come back in 5 minutes and let's talk. I'm starting the timer now. In 5 minutes, you come back and let's talk. Blessing, you have something to say? So let me repeat. Download this leaf color chart in your phone. I've shared it in the WhatsApp groups. Find any crop around you, anyone at all. Make sure you're back in the sun before you now put the leaf on this leaf color chart. And find which of these colors on the chart is closest to the leaf itself. Then come back, let's diagnose that particular plant. 5 minutes. We have less than 3 minutes to come back. I hope you have found some interesting result. If you have, please, I'm going to call randomly so everyone participates. Has anyone got some result? Lot, I see your name first. I'm going to call you first. Okay, Baba, go ahead, please. Then Mayam, then Mary. Baba, go ahead. If Baba is not ready, Mayam or Mary, you can go ahead.
Good morning,
All right,
sir.
sir. Good morning.
Good morning. So tell us, what did you
Yes,
find?
sir. The color is under the number 4, sir.
Number 4. Let me go back
Yes,
to
sir.
the. Okay. So number 4 is not so low, it's not so high, it's in the middle. So the nitrogen level in that plant is average. You will need,
Okay, sir.
if it is a fully developed plant, or if it is like 1 month and something old, you should see number 5 color closer. So that
Okay.
plant need a small nitrogen in order to perform better.
Yes, sir.
But that's,
Thank
you
you.
see, just by using that chart, now we can diagnose that that crop needs some nitrogen. Mary,
Yes, sir. Thank you, sir.
thank you, Mary.
Yes, sir.
Uh, Mayam,
Okay, good morning, sir. So
yes.
I can see that mine falls under number 5.
Okay, awesome.
Yes, sir.
That's a very healthy plant there. Super, super healthy plant. Nothing to worry about. Uh, what plant is that? Is it a grass or a plant or a crop?
It's not really a grass, it's like a plant, but I don't know what it is.
Okay, fantastic. That plant is doing very well. Thank you very much. Timothy, James, Baba, anyone can go, please.
Good morning, everyone.
Good morning.
Yes, the lift I text it number 2.
Number two is is deficiency is a big problem. That
Oh,
plant needs some nitrogen and also some water, most likely.
oh,
Yes, that's a very sick crop. Thank you, Timothy.
thank you, sir.
Faith, James, Baba, anyone can go.
Okay, good morning, sir.
Good morning, James.
Yes, sir. I checked 3 crop plots. The first one, golden melon, tomato, and pepper. Now, the golden melon, it
Mm,
falls under number 4.
okay,
The tomato, number 3, and also the
okay,
pepper is number 3. The pepper was transplanted about, let me say, 2 weeks ago.
okay,
The tomato has been there for over 2 months. Then the golden melon to about 3 months.
okay. So, anything on two is like very poor, So, all of them, from what you have said so far, they need some attention. They need some nitrogen application. You might do well to apply some on it. Maybe get small fertilizer if you are interested in improving the health and the yield. But that's a clear indication of problem. Um, for transplanted crops, you should be between 4 and 5 because with transplanting you have crossed the early stages, which should these colors can be okay for early stages. This one, particularly 3, can be okay, but this completely unacceptable too for any crop at any stage. You should be seeing something between 4 and 5. 5 is best. So all of them has a problem. Okay, I'll take one more. Faith, Paul. We've taken Timothy already. Faith, Paul. Anyone? Please go ahead. Faith, Paul. Any of you can take.
Okay, good morning, sir. I don't know if the else can hear me.
Yes, I can hear you now.
Okay, I actually planted cassava and beans, and
Uh-huh.
at the early stage of the cassava, the color is started from color 3, then
Mm-hmm.
I think gradually it's becoming color 4. So I think I don't know if there's a problem, but I think, or probably maybe it's the process, but it
Mm.
started from color number 3 and it's now on color number 4. And for the beans, it's color number 5.
Okay. If it is early, color number 4 is okay, but you would always not go wrong if you do some dosing of nitrogen on that plant to get it at 5. 5 should be, at least for nitrogen, 5 should be your benchmark. Um, of course, there are other nutrients to worry about, but these are purely a test for nitrogen levels in the crop. But I think you are doing okay, but it wouldn't hurt to get your numbers from 4 to 5 as soon as possible. All right, Faith, go ahead. Last one, Faith. Baba, go ahead, please.
Hello?
Go ahead, Baba.
Mine beans and it fall in level
Level what?
5.
Level 5 is excellent. So your crop is doing nitrogen level wise is doing well. Thank you, Baba. I can't hear Faith, so I'm going to move on to the next one. But Faith, if you can hear me, just feel free to interrupt.
Hi, can you hear me now?
Yes, go ahead, Faith.
Hello.
We can hear you. Go
I
ahead.
think my own falls under number 3.
Number 3. Number three is not good. It has some nitrogen, but it's not enough. It's a deficiency. Number 2 is no, like 0. Not 0 per se, but very poor. Number 3 is not good. So that crop needs to upgrade from 3 to 4, or 4 to somewhere between 4 and 5 would be a good upgrade. Thank you, Faith. And thank you everyone for trying. We will try to find some of these, like purchase this chart and, try and send it across to as many of you as possible so you can use it as part of your work looking forward. We're coming to that stage, definitely. Does anyone know what this is? If you have, please just unmute and tell us. Anyone? Okay, Marufat.
A fertilizer chart.
A
Application chart.
fertilizer. It's a very good attempt. I like the way you're thinking about this. But it's something else. But that's a very good attempt. Very good attempt. Anyone else? Can some of you just be conscious of your microphone? Listen, your microphone is on. I just turn it off, please. Let's have some quorum, okay? Mayam, go ahead. Okay.
Good morning, sir.
Good morning.
I think this is a soil test result.
You think or you know?
Okay, this is a soil test result indicating the level of nitrogen, the organic matter in the soil, the pH level, as well as phosphorus, potassium, and other micronutrients contained in the soil.
Awesome. That's correct. That's actually a sample of what a soil testing result looks like. Thank you so much. So, and this leads me to the next tool, which is the site-specific nutrient management. So, I understand that in our country, we only know of two, most persons know of two fertilizer, NPK and urea. Of course, there are the ones that were there before them, like the DAP, the MAP, and even the phosphate salts and etc. So we're going to look at what kind of nutrient levels to expect in our soil testing result. And then we're going to see how to use that result to calculate how much fertilizer is needed to achieve the best result for that farm. Now, as I said, there are a few factors that decide if a farm is doing great. And part of what you are going to do is take this knowledge and try to monetize it. Prove it first and monetize. Show farmers that soil testing can actually lead to the best results ever. Now, for organic matter, which is the SOM, the higher the number, the better. So there is no ceiling. Well, there is a ceiling, but yeah, the higher the better. For N, the result should show 40 ppm. If it is 40 ppm more 40 ppm or more, then you are okay. Now, for any soil result that shows 40 ppm, you don't need to apply fertilizer on that soil, at least. Sorry, urea fertilizer. So you see, you can save that 60 of how much thousand does it cost now times number of bags that you plan to buy just by testing and making sure your soil has it. For P, the range is between 25 and 50. ppm means parts per million. It's a unit for testing. There is also grams per kilogram, there's milligram per, there are so many units, but this is much more common across different parts of the world. For K, you're looking at 40 to 80. For CEC, K is potassium, P is phosphorus. CEC means cation exchange capacity. Now, if you remember when I was explaining earlier, and I said that the roots of the crop uptakes the nutrient from the soil, right? Now, the process through which the nutrient goes from the soil into the plant through the root is called cation exchange. Now, the level of cation in the soil will determine how effective the crop can uptake nutrients. So you might have enough nitrogen and all those nutrients in the soil, but if the cation exchange capacity is low, the crop may not be able to uptake them. So they might end up leaching, and then you have bad harvest. Sometimes you will now say, oh, the fertilizer did not work, or this and that, or the seed did not work. Meanwhile, the problem might have been the cation exchange. Now, these are all sort of connected, which we will find out very soon. The next one is the pH. A pH level has to be between 6 and 7. The closer to 6 it is, the better. The closer to 6, the better. So somewhere in the middle would be a good point. When it is high, you can use sulfur. You can also use liming to reduce it. There are other ways to do that. But if you're going to use sulfur to lower your pH, make sure the sulfur level in the soil is not already above this or below this level. Sorry, above this level, because you might be causing more harm than good if you use sulfur. That's why either use sulfur or use liming material like ash. For calcium is 300, for magnesium, blah, blah, blah. All right. Okay, let's do some example. I want you to open Google Maps on your phone. All right. For me, I'm using the site for our chili farm, our demo chili farm. This is where the farm is. So I want you to open Google Maps. When you open it, press and hold your current location. So you're going to see a blue dot that shows your current location. So press and hold it, and then something like something pops up. I'm not using my phone, so I might not be able to, but I think I can show you that. Let me join with my phone. The point is, I want you to collect the coordinate of your location so that we can use it for the next step. We're going to do soil testing for your location using just your farm coordinate. All right, I think I'm good now. Let me share from my phone and then show us. Where is the maps? I'm sure some of you have figured it out already. I'm going to stop sharing here and then share from my phone and show you. Uh-oh, I do not have the permission to share. So let's try switch device. Uh-oh. Okay. How do I say this? Just a minute. Let me find a screenshot. I might have one somewhere. I might have one somewhere. Just a minute. Has anyone figured out what I'm trying to say? So if you open the Google Maps and you press and hold your current location, something pops up. You will see the longitude and latitude. Has anyone seen that?
Yes, sir.
Okay. If you have seen it, then fantastic. So we can save some time. So I want you to take note of that longitude and latitude number. In fact, if you press it, it's going to copy. All right. So copy that longitude and latitude. Then let's go to this website. I'm going to put it in the chat. ruralfarmershub.com. So if you go to ruralfarmershub.com, you're going to see this page. Since you're using a phone, it's going to look something like this. Let me change the media.
I'm using the system now, sir.
Okay, if you're using a system, it's fine as well, but you're going to see something like that. So you're going to see this page regardless. Now, when you're on this page, I want you to click Free Soil Analysis. It's going to open this page. Free Soil Analysis.
Yes, I am there.
Okay. I want you to enter the latitude first. If you're using Google Maps, the latitude is the first one. So enter the latitude number, just kind of paste it here, and then paste the second number, longitude, here. Then select topsoil in the drop down, then click continue. You are going to see a result like this on the next screen. The pH, the nitrogen, the phosphorus, very basic result, okay? Okay. I'm going to stop sharing so I can go to my writing pad and we can discuss your results. All right. So let me present, connect to app, accept. So let me start with Mayam, because I think she's the one who is participating with me, but I'm going to call other folks as well. So Mayam, tell me what you see. What is your pH level? Mayam?
Yes, I'm
Hey.
with you, sir. Yes, I'm trying to figure this out now, sir.
Okay, let's go to another person. Faith, do you have some result for us? I'm going to write out my own result as well. Aniebet, Emoshoke, any of you can go, please.
Yes, sir, I have results.
Oh,
Aniebet
Okay.
has results.
Okay, let me just write out mine first, and then I will take yours. 720, 89. Okay, Aniebet, go
Yes,
ahead.
sir. pH is 5.9.
5.9,
Nitrogen is 1.2.
1.2,
Phosphorus is 6.4.
6.4,
Potassium is 59.3.
59.3.
Magnesium is 108.9.
No, let's stop at phosphorus. Thank you so much.
All right, sir.
Emoshoke,
sorry, sir. Mine is more of a question. I don't know what blue icon we are pressing on the Google map.
okay, usually if you open Google Maps, a blue dot appears showing your current location because we want to test for the soil content in your current location. But you can pick anywhere else. It doesn't matter. We are doing an example, okay? You can pick anywhere else. You can just press and hold anywhere on the map, and then you will see something will pop up showing you longitude and latitude. We just need to take that and run the analysis on this free tool. Make sense? Okay, let's discuss the result from a nearbed. So if you remember, and I'm going to try to write it out on this board so that just give me a sec, okay? Let me write out what we had just for these values only. So for pH, we said we want to see anywhere between 6 to 7. For N, we said approximately 40 ppm. Take note of ppm because if you notice the unit we have is what? Is in grams per kilogram. The unit you have on your result. For P, we said anywhere between 25 and 50 ppm. And for K, we said anywhere between 40 and 80 ppm. These are the optimal values that is accepted worldwide when it comes to these macronutrients. So Aniebet, I think the first thing I need to say before I call on Aniebet is we need to convert the nitrogen from grams per kilogram to ppm because our benchmark here is ppm, right? So how do you convert? How do you convert from what's it called?
Grams per kilogram.
From grams per kilogram to ppm. I think you multiply by 10, but just 1 minute. Let me confirm. I think the factor is by 10. Just a minute. Let me check my reference. If anyone know, you can help us out, but I'm going to find it. If I remember, 1 ppm is equal to 1,000 milligram per kilogram. But I'm going to confirm that. I'm really surprised that many of us have not done or used soil testing. It's kind of it's a bummer, really, if you think about it.
So I don't know. I don't know if I got the right one. It's actually telling me that while I'm trying to get the details, it's telling me that value must be less than or equal to 90 points, and that's not what I have. I guess that's why the result is not coming up.
The value must be less than 90. So we are putting the wrong coordinate then. Coordinate has
Okay.
to be something point something something and then something point something something. So why not copy them one by one? Or when you paste them in the box, you try and make sure you're copying the right thing, okay? The problem is what you copied.
Okay. Okay. Let me try.
Look at the coordinate, you're going to see something times point something something. Very important. So what I have here is that to convert from kilograms, from grams per kilogram. Okay, somebody's asking, Olabode, when you enter the, let me do it again. I think it's better. It's better if I do it again. So let me share my screen again and show you. So when you go to the website, ruralfarmershub.com, you're going to put in the longitude and latitude. So let me show you, just for the sake of Mayam, let me do it again from my end. All right. Let me do it again from my end. So if you look here, you're going to see the Google Maps, and I'm going to put the location of our demo farm, which is here in Ebonyi State, one of our demo farms. You look here, you see two numbers, 5.9 something something, and comma, 7.6 something something. I'm going to copy this number, and I'm going to go back to this page. So I'm on Rural Farmers Hub first. I will click on Free Soil Analysis. Here, I'm going to paste what I just copied. But remember, I copied two things, right? Look, I copied both the longitude and latitude. Then I come here, I'm going to paste it. What have you noticed? Both numbers were merged. The breaker here is 9 and 7. So I'm going to look for 9 and 7, which is here, and delete all this because the other one is 7 point something. You notice it? See here, 5.99. The other one is 7.6. 5.9. Then 7. I'm going to delete all this and then put them here, or put a point because there's a point somewhere, right? Now this is more correct. You see? Let me do it again. On the map, I'm going to copy this. And then I go to the website. I'm going to paste. Let's delete everything at once, okay? I'm going to paste it like this. I copied both of them. But because this box only accepts numbers, it ignored my second comma, the latitude, the longitude, right? It ignored it. Look here, you would see the comma is after 9. Then I have 7.6. So let's go back to this form. Depending on your phone, I will advise you to copy them one by one. If you can paste them somewhere, then copy them one by one. 7.6 is somewhere here, but this field only accepts numbers. That's why it deleted that comma and everything. So I'm going to delete this, and I'm going to paste again and look for 7.6 here. So copy them one by one. If you have to write it out, and then type them one by one. However works for you, okay? Then you select the topsoil, and then you click continue. Okay? That's how to do it. Okay, let's proceed because we are running out of time very quickly. Oh my God, this is so much fun. So this is how we're learning how to interpret, how to get and also
Yes, I
interpret.
got it now, sir.
Awesome, fantastic. So I'm very happy that nobody has done soil testing. So this would be like a very good opportunity to create more awareness on soil because it's very important if we're going to solve food security. Okay. Now I just confirmed that for you to convert from grams per kilogram to ppm, you multiply by 1,000. So it means we have to multiply this by 1,000. Am I correct? I think I'm correct. By 1,000 means 1, 2, 3. 1. How do I clean this? Let me see. 1,400 ppm. That's for me. For Niebet, 1,200 ppm. All right, are we together? Now, from our benchmark, which is here, this is our benchmark. Is the nitrogen level okay for this particular soil? Niebet,
Sir,
the nitrogen, is it okay for this particular soil? For your soil?
the nitrogen is too much.
It's too much, it's more than sufficient. Thank
Yes,
you.
sir.
So we do not need to apply urea on this farm at all. Now let's look at the next one. pH. Is the pH okay?
Yes, the
It is
pH
not.
is okay.
It is not. It's 5.9.
Okay, 5.9.
We're looking for
Neutral.
67. So we have our first question mark here. pH. Is our phosphorus okay?
Phosphorus is too small. It's not okay.
You see, we have our deficiency. Is our potassium okay? It's literally on your screen. Look at the benchmark and look at your result.
Yes.
This is okay. This is okay. So we have a pH and phosphorus problem. Now, if you are growing tomato, this is a big concern. Tomato can never do well on this kind of soil. Never. You need to improve phosphate in order to get good result from tomato plant. For some crops who are not so much phosphate hungry, you will be okay. So all you need to do if you're doing tomato is to buy the potassium powder. I think it comes in like liquid and also in powder form, and apply just this alone. But the question is, how much phosphate do you need to apply, right? So you don't over apply or under apply. We'll come to that. Michael.
Please, I want to know, is it just the nitrogen you are converting to ppm?
Yes, because the result for P and K is already in ppm. If you look at your result, you will see the units are on the side just before the numbers.
Okay.
For P is already ppm, for phosphorus is ppm, for potassium is ppm. The only one that is not ppm is nitrogen, which is why we converted by multiplying by 1,000.
Okay, thank you, sir.
You're welcome. I am not very sure about that 1,000, but let's keep it. I think it's correct because with milligram, it's going to be the same. 1 milligram per kilogram is equal to ppm. Okay, it's correct. Multiply by 1,000 to convert to ppm. Okay, if you look at my result, the one I got before I asked you to check, you see that my pH is also problematic. My N is good. My P is problematic. And my K is good. So myself and Aniebet, we have the same problem. I need more results, please. I need more result. James, please.
Yes, sir.
Please tell me what you see.
Okay. My pH level, sir, 5.80.
Okay.
Nitrogen, 1.10.
Okay.
Phosphorus, 7.20.
Okay.
And the potassium, 65.70.
I think we all have the same problem, right? pH is a bit low. N is okay. Phosphorus is bad, is low. This is okay. Now, the question is that we don't have the same level of deficiency. Some persons have more deficiency than the other, like if you see 6.4, 7.2, 7.2. So, Andrew Hahaldi, what's your result, Andrew? Bless and allow. Tell me your result. Blessing. Chuku, Imo Chuku. Chukuma Ojiogo. Fatima Ibrahim. I need you to respond. Emoshoke, please.
Sapti, before I speak about my result, am I supposed to select top surface depth in the drop down?
Yes.
Okay, so the result is for the pH level, it's 5.90.
Okay.
Then for the nitrogen, I've not converted it, it's 0.70.
Okay.
Then for the phosphorus, it's 9.0.
9.0.
Yes, sir.
Okay, the last one.
Potassium is 65.70.
So the same problem. Thank you, Emoshake. Paul, nobody signed up to get this result, okay? You just need to click on the button that says free soil analysis. It's on the homepage. Nobody here signed up to get the result. It's just there. So why not try and type in, Paul, try and type in the numbers, write them down somewhere and type it in with your keypad instead of copying and pasting. I think that's giving us some trouble. All right, then let me know. Mayam, please.
Okay, so for mine, for pH level, I got 6.00.
6.0.
Yes. Then for nitrogen is 0.60. Then for phosphorus, I got 9.00. 9.0.
Okay.
Then potassium, I got 59.3.
Okay, so your pH is good. This is the first good pH. Your N is good. Your P is a problem, and your K is good. Okay. I think we have. I'll take one more. Mary, do you want to share with us? Then we'll talk about how to calculate.
Sir, please, mine is a question. A call entered my phone and I was disconnected from the class. So I don't know where to get the number to copy in the longitude and the latitude, sir.
Okay, you go to Google Maps. You either pick your current location or you can pick anywhere. So just press and hold anywhere on the map. Either you press and hold your current location or anywhere else on the map. Just anywhere. Press and hold. Something will pop up and show you the longitude and latitude.
Okay, thank you, sir.
All right, you're welcome. Let's take one last one. Olabode.
Yeah, hello, sir. So can you
Please
hear me,
go
sir?
ahead.
So
Yes, I can hear
yeah, the result goes thus. Yeah. The pH level as written here, I have 6.00.
6.00.
The nitrogen 1.10.
Okay.
Phosphorus 10.00. The potassium 80.30.
Sorry. Phosphorus is 10.0. Can you say phosphorus again? Olabode. I thought I heard 10 and 80. Correct me if I am wrong. Olawode? Okay. I don't know if I got you wrong, but just jump in if I got it wrong, okay? So what we can see here now is, I mean, it's very obvious that majority of the point where we are now, it varies from place to place. No two places have the same, result. So let's calculate for, let's start with, let's see who is here. The first one is Anebet. Let's start with Anebet. And I'm gonna try to copy this. Select. Okay. So I have a Anebet's result here. All right. So what we're going to try to do is we're going to try and calculate how much fertilizer does Anebet need. Anebet, can you jump in so I can have this collaborative calculation with you? Anebet, please hurry up. Anebet. Okay. Does anyone want to volunteer to be the manager of Anebet's farm in this example? I want it to be collaborative, okay? Anybody? Volunteer. Chukuma, do you want to volunteer? Chuku?
Are you referring to Chukwuma Chukwu?
Chuku, please.
No, it's like someone bears Chukwu there. You're referring to Chukwuma Chukwu, right?
I'm talking to you. Do you want to volunteer to represent Anebet?
No, I just want to give my own result.
Okay, but we're done with the result. Go ahead.
Okay, so my result, the result I have here says pH level is 5.50, nitrogen 1.10, phosphorus 8.0, potassium 80.50, and magnesium 89.0.
That's all.
Sorry.
Let's stop at. Okay, thank you, Chuku. That's all. So here you can also tell that the pH is below. The N is good, right? Because we said N, this is times 1,000, 1100 ppm. It's very good. The P is problematic and the K is good. Similar problem. So, Anebet, can you jump on the call, please? Save me some time.
Yes, sir. I'm with you, sir.
Okay, so Anebet, this is your result. Can you tell us what crop you would like to grow on this farm?
Okay, I would like to grow habanero pepper and cucumber.
Okay, let's stick with one because soil analysis requires you to pick just one crop. Okay, so we're sticking with pepper. I'm gonna quickly check. I'm gonna quickly check the reference table for nutrient removal rate. But while I'm checking that, can you tell me what is your expected harvest in terms of tons per hectare from this farm?
Okay, I'm expecting 1 ton per hectare.
1 ton per hectare. Isn't that too small? Can you use ChatGPT, ChatGPT, and ask it what is the average ton per
Okay.
hectare for pepper, for that pepper? Let's see what is the average you should get normally in Nigeria. So be sure to specify. Someone else can also help out. Ask ChatGPT what is the average ton per hectare for what type of pepper again? Did you say
Habanero pepper.
habanero? Can I spell that? Habanero.
HABERNERO.
HABERNERO. I know that nero is an Italian word for black. It's black pepper, yes?
No.
Okay. So I'm gonna take it as habanero pepper. So what do we have in terms of average yield for habanero pepper? Chukwu, please go ahead. Okay, Mary.
Yes, sir. I used the chat GPT for it, and
Okay.
it said 3 ton per hectare.
3 ton per hectare.
Yes,
So
sir.
let's see expected yield. 3, like pharmacies sometimes. 3 ton per hectare. The doctors. Habanero pepper expected yield is 3 hectare. So now let's do a quick lookup on something called nutrient uptake. Just follow me, okay? In order to produce 1 ton of habanero pepper, are you with me? In order to
Yes, sir.
produce 1 ton of habanero pepper, the pepper itself, the crop needs to remove a certain kilogram of our missing nutrient here, which is our K, potassium. It's called nutrient uptake or nutrient removal rate. It's a science. Every crop has its own nutrient removal rate. So for every ton of pepper produced, it must need a certain kilogram of phosphorus or potassium in the soil to make it. Now, can somebody ask ChatGPT what is the nutrient removal rate in kilogram per ton for habanero pepper? Can somebody ask and give us that number? I don't have it in my reference table. What is the nutrient removal in kilogram per ton for habanero pepper? Okay, I think we're done with Aniebet now. Let's just wait for that response, and then we'll calculate how much we need to grow 3 tons per hectare. Can somebody help us with ChatGPT, please? What is the nutrient removal or uptake in kilograms per ton for habanero pepper? James, please.
Okay, sir. For nitrogen.
Okay, give it the one for K only, because that's what nitrogen is okay, right? From our calculation, nitrogen and
that's 2.7 2.76.
Sorry, for potassium, for
For
phosphorus. Oh my
potassium.
God.
Can you hear me, sir?
For phosphorus, that's the one we're lacking. Sorry
Okay.
for the mix-up.
For phosphorus, sir.
Hmm.
0.78.
0.78. What's
Yes,
the
sir.
unit?
Kilogram
The
per
unit,
ton.
0.7 kilogram.
0.78 kilogram per ton.
0.78.
Yes, sir.
Uh-oh. Now, what we notice here is that the number is very low. So this plant doesn't even need fertilizer to grow on this aniebed farm. Have you seen? The available nutrient is 6.4, but the plant habanero pepper only needs 0.78. So we don't absolutely need no fertilizer for this farm. We can now focus on improving what? Just the pH. Are you seeing what we are doing?
No, sir.
Aniebed.
Yes, sir. I think the unit is in this unit is ppm. So we have to convert that kilogram per ton to ppm. So it will now require nutrients.
You
The
mean
the
this
unit
unit
we
is in
have,
ppm?
yes, this our unit is ppm.
Are you sure?
Like yes, the result I gave is in ppm.
I know, but already converted
But
the
the answer
M.
that he gave now is in kilograms.
Yes, I'm coming. We are talking about two different things. I'm coming to that. So what we are looking for two variables. We are looking for the expected yield, which is this one, and then the nutrient uptake, which is this one. They're not related to this yet. We are coming to this. Okay. I got you now. I got you, man. I got you. My mistake. My bad. You're right. I got you now. So let's just go ahead and calculate the nutrient required. You're correct, Aniebet.
Thank you, sir.
Nutrients required will now be expected yield, which is 3, times the nutrient uptake, which is 0.78. Now, if we times this, now if you look, you will see for the unit, ton per hectare times kilogram per ton. Ton cancels ton. So the unit is going to be kilogram per hectare, right? So if we times this, what do we get? 0.78. 0.78.
2.34.
2.34
Yeah.
kilogram per hectare. For those of you that run away from math class, you thought you were going to be free in agriculture, but you're not free from mathematics. So we need 34.4 kilogram. I hope I'm getting the right maths. Yes, we need 34. I think I'm getting the right maths. 3.34 kilogram per hectare. Okay, let's keep going. We will know for sure very soon. So this is our first result. The next thing we need to do is to do the available nutrient, which is now this. That's the neighbor question. This is our first step. This is our first step. So for available nutrient, we now need to convert this 6.4 ppm, need to convert it to kilogram per ton per hectare. And the conversion rate, since already in ppm, is that we multiply by 2, then multiply by 1.2 kilogram per hectare. That's the unit for conversion. This should be 2 over 1 ppm. How is this even done? Anyways, this is the conversion from ppm to kilogram per hectare. So if you multiply 64, sorry, 6.4 by 2, and then by 1.2.
We'll be having 15.36.
50.36.
15.
15.
15.36.
So this is in kilogram per hectare. So the next thing we have to do now is to subtract what we just obtained from this one. So the gap will now be what we have here minus what we have here. So 2.34 minus 15.36. You see, we're having a negative value, right? We're having a negative value. We do not need fertilizer for this farm, period. If we grow habanero pepper on this farm, it's a negative value, so we don't need. If we have a positive value, then that's the gap that we're going to fill with fertilizer. But as it stands, we do not need fertilizer for habanero pepper on a near-bed farm. Our main focus is to improve the pH level to become 6 by adding some sulfur or some liming material, period. I have just saved a near bed. How much? How much is one bag of fertilizer? 40,000. Let's say a neighbor was planning to buy 3 bags. I have just saved a near bed 120,000 in fertilizer. Money that he would have spent that is not required in the first place. Does it make sense? This is the real value of soil testing.
It makes sense. Yeah, nice one.
Am I okay?
Sir, I have a question. For the pH of 5.9, I thought it's closer to the optimum level, so there's no need to maybe add or change or improve the pH level. Is there a problem with this 5.9 since the optimum is 6? It's between 6 to 7.
0.1 can mean a lot. If you look at 1 hectare or 1 acre, it can mean a lot of acid. So it's always, of course, you can ignore it for sure, but it's always good to just be within the optimal range, because in the end, what we are doing in this whole activity is to optimize the soil for best result, so that if the result doesn't come, you can say it's an act of God. That means, and that's beyond our power, but yeah, it will be good to apply ash or some sulfur to bring it to 6 point something. Maximum optimal result. Michael, please.
So mine is also a question. Hello?
Yes, I can hear you. Go
Please,
ahead.
can you hear me? Okay, mine is a question. I know that along the production cycle, we should be needing a resupply of these nutrients. So are we to do periodic tests on the soil, or we just supply according to what we are getting, like the produce we are getting? Because these are fruits. When the fruits are being produced, I know they are losing some of these nutrients to the fruits. So are we to supply with time, or do we have to do soil tests again and again frequently before supplying?
So usually, let's use this Aniebet example. Aniebet has an oversupply of all nutrients. So as he keeps harvesting the fruit, this available nutrient will be dropping. So we would expect him to do another soil testing in, let's say, 2 or 3 years to see if he still have a surplus. So most soil testing results should be done. If you are doing green crops for an intensive farming, you should do it every year. Let's say if you're growing maize and rice and all those intensive crops that are very heavy on nutrient, test every year. But for tree crops, maybe every 2 years, 3 years, do a testing just to be sure, because you don't know if the crops have removed more than what you already have, or if you have leaching, or if you have erosion. Those things can also deplete soil nutrients. So it's always a good idea to test every 1 or 2 years, or 2 to 3 years.
Okay, sir. So for this particular one, you're saying that if I'm raising habaneros, I don't need to test this soil again for after maybe 1 or 2 years.
Yes, you don't need to test until maybe 2 years, from what I'm saying.
Okay, because what I'm saying is I know that this thing produce fruits like weekly or even less than that. So I feel that the rate of production is too fast. That's in a couple of months that they might be exhausted. I do pepper, and I usually do use a drip irrigation system to fertigate the entire field once in a week. But I feel I don't know. From what you're saying, that means I am wasting resources.
Are you getting 3 tons per hectare?
I think I should get more than that because mine is not
Okay.
up to a hectare.
Okay. If you do the
Yes.
maths, then you're getting 3 tons per hectare and above, then you're fine. And maybe you can try not to fertigate, and see what happens. You know.
All right.
Alternatively, just do the soil testing. That's the best result I can give you. Best answer I can give you. Do the soil testing, do the maths. The rest is easy to decide what you want to do. There are other things you can optimize: the soil structure, the organic matter. These ones are just for the nutrients.
Yes, sir.
There are other parameters that we can optimize, which for the sake of today's class, we don't have time for that. But thank you for that. Let me take from Morat and then Maya. Marufat, please. Or Mayam, anyone.
What's the accuracy level for that soil test?
Soil testing are pretty consistent. So for this particular we're doing, it's pretty high. It's over 80%. Because the model, they are AI models, they are trained with historical soil information. So these are actual soil data that have been tested across many years in so many countries. So they are pretty accurate. I must also say that even though we train with soil testing is not the holy grail, because for example, things like nitrogen, from the time you collect the sample to the time you take it to the lab, little temperature changes can influence the property. So it's not a holy grail. But in terms of correlation, is a very strong one. It's very close. And you can actually, if you have access to a lab, you can test and compare results and let us know. But I guarantee it's going to be very pretty close to what you get in the lab for less cost, matter of fact.
Then another thing, why are you using just one coordinate? For example, like being a farm, an hectare of a land can have different coordinates and different
Very
properties.
good question, Maya. Very, very good question. This is why it's called on the website, it's called free analysis. It's not meant to replace a proper testing where you take into account the entire hectare. So free testing, we need to put somewhere that this is not is free, but you cannot use it alone to recommend soil information for sure. But that's a very important catch. So anyone on the call who is planning to use this free soil testing in actual decision making, please do not. You will need to collect the whole boundary of the farm to get a better analysis, which is a paid feature, by the way. Okay, so please do not use this on an actual farm. We're only using this as a demonstration and also for educational purposes. Murufat, that's a very important catch. Thank you so much. You just saved me, saved my ass. Thank you so much. Mayam, please, last one, then I can go to the next.
Okay, sir. You just said something now before Marufat asked a question. You said something like due to maybe weather change or something, the nitrogen may change a little bit after the soil testing. Now, is it possible for you for one to still try and test the soil again after planting to be sure that everything is fine? If it is not, then one can easily use other means to make sure um he or she make correction to get a good harvest.
Mm, uh, I do not recommend that, especially if you don't have the budget. The initial soil testing before planting should be enough to make a decision in that planting season. The next time you want to test would be immediately after harvest, I would say, if you so wish, and then you take that post-harvest testing into the next planting cycle. I would not recommend to do it in the season, in the middle of the season. Some people do, just to get a quick heads up, but I don't think it's super relevant. Now, this is just a recommendation. I'm not advising. Okay, if you want to do it, it's fine. But I think the one you do before should suffice. So let me kind of go back to. I wish we can do one more, but we're out of time. At least to do the one where we can see how many bags is required. So let's say we flip this number. Let's pretend we flip this number and do 15.36 plus 2.34. The gap we're going to get will be calculator. Turn this off.
13.02.
Sorry?
13.02. 13.02.
Looking for 30.02 kilogram per hectare. This is the gap. Let's say we flip that, okay? That we're looking for. So, because we are talking of a P fertilizer, right? We're talking of a P fertilizer in this case. So, what kind of P fertilizer exists in terms of, for urea, which is very common? We know that one bag of urea contains 56% of nitrogen, correct? Now, for phosphate, what kind of phosphate fertilizer exists? I know we have diammonium phosphate. I know we have monoammonium phosphate. I also know we have triple superphosphate. These are three of the most common phosphate fertilizer because, we are talking about the deficiency in phosphorus, right? So these are the three phosphate products that I know of. And in terms of percentage of phosphorus inside each of these bags, right? We have a few, the first one is 46%, 50%, and 46%. They are all super high phosphate content, okay? But the difference is that for diammonium, for DAP, it contains 20% nitrogen. And remember, our farm does not need nitrogen, so we cannot use DAP, okay? For MAP, it contains 10% nitrogen, but our soil does not need nitrogen again, so we cannot use MAP. For triple superphosphate, it contains 0% nitrogen. It's purely a phosphate fertilizer. So our choice of fertilizer will be what? Will be TSP. So our choice of fertilizer is TSP because it does not contain nitrogen or any other, it's just purely phosphate. And TSP contains what? About 46% phosphorus. So to my last, the last formula now will be, Alabode, question?
I don't know if you are done, sir, but it's a question I want to bring us a bit back, sir. Should I go ahead?
Okay, let me just finish this.
All right, sir.
So if we do this maths, then we were gonna have 13.100 divided by 46 times by 13.02. So we're going to have 23.3 kilogram per hectare. This math is not correct, but I think it's correct. So if I
Sorry,
divide in,
46% of it should be 46 over 100 instead. Times, or
no,
we should just say 0.46 times 13.02. So we'll be able to get the
ignore
answer.
this. Ignore this. This is correct. Out of 100%, just 1 minute. This is correct. So we need 23 point, 23.3. I'm gonna have to confirm this, okay? I think this formula is correct.
Excuse me, please. Excuse me, please.
I will.
We are trying to have 46% of 13.02. Am I correct?
No. What I'm trying to do is, I'm trying to say that for a whole, for a whole bag, let's say 100, right?
Okay, for 100. Okay, out of 100.
Yeah, for a whole 100, there is 46. Let me confirm this, okay? But this is the formula that we normally use for this. But let me confirm by next time we meet. But what we're trying to do is to say for a whole 100, we're dividing it by what is obtainable in that 100, and then we'll multiply it by the gap. But let me confirm, okay? Just give me some time, I'll confirm. But barring that this formula is correct, which I think it is, it means that we need 23.3 kilogram per hectare. So I'm going to explain this later. Just let's have this conversation next week, okay? Or the next time we meet. But this is how we determine how many bags we need, this last section. But let me clarify the next time we talk. Olabode, question, please.
All right. Yes, sir. I remember that last week I asked a question regarding a pepper plant beside me, which got at early stage, it was very fresh, doing fine. But later on, it gets burns and runs. That you asked me to get to share the coordinates of the place, but I was unable to do that last week. Yeah. I now say that with the analysis that we are able to get today now, this soil sampling, can we know the cause? The cause of that pepper getting runs.
Okay, give me your result. Is this your result from that farm?
Yes, but that 9.1 that you wrote is 1.1, not 9.
Okay.
That of nitrogen is 1.1.
Okay. So, Olawode, your pH is good for sure. Your N is good. And this explains why in the beginning, your pepper is so green, because you have surplus nitrogen. Chlorophyll is like 80, 90% nitrogen. So the green is because you have surplus of this, or you have shortage of this, not this. You have shortage of phosphorus, and this became this reflected on the farm, just like you described. So you need to, I don't know if it is still early, if it is too late, sorry, but you would need to improve the phosphate level on that plot of land, and then your pepper will do well. Phosphorus is responsible for, I forgot, but you should know that. But in this case, I know vegetables require lots of phosphorus, for sure. And your soil is lacking it by a lot. And this is the cause, one of the causes. Your pH is good, your nitrogen is very good, which is why it's so green at first. So maybe if it is still early, or if you want to try again, apply phosphorus in a new germination and let's see what the difference is between with or without phosphorus. You can buy the powder one or the liquid one, I don't know, the foliar one. I think they should all work. And then let's hear it before you have, maybe in a few weeks you can give us results. Yeah.
Okay. All right. Thank you, sir.
But your result is pretty evident of what the problem is. Now, there could be other challenges, like the soil texture. If you have a dominantly sandy soil composition, then you probably have another problem, because you're probably leaking water, or the soil is leaking water. So mineralization may not happen. So even though you have phosphate, if the soil is sandy too much, it cannot, the cation exchange is going to be very low, the CEC very low. So we're going to look at all that. Maybe if you can send me an email with your coordinate, let me do a much more detailed analysis and share with you.
All right.
All
Thank
right.
you. I so much appreciate that, sir. Even with the analysis you've given now, sir, I can even factor some of the causes of the problem as well.
Yeah,
Because in
definitely
that
is a
area,
phosphate problem. Definitely.
because the place is a bit, the topography of the place, the location is a bit slopey, and it contains more sand. Because even that place, to me, is supposed to be lived for just the children in the neighborhood, just to engage themselves in some exercise and play football. But that person just try to convert it into farming and something to plant that pepper. Though he has been advised not to do so, but not an agriculturist. So I think that is what is leading to this. So the place is
However, you can improve the soil as well. You can actually improve the soil to grow pepper, but it will require you adding some organic material in that plant, adding some biochar, just overall improving the soil texture and quality, and then it can do well. So that means even cover crops too can help, but you need to have a lot of organic matter in the farm, in the soil, for sure. Organic matter will increase compaction, because if it is too sandy, yeah, that might be a problem. Since you say it's a slopey area as well, you might need to also do some barricade or bonding at different. Anyways, we can talk about this later. But let me try and wrap up today, because we are.
Thanks so much, sir.
1 minute out of time, and how do I stop sharing? Okay, let me try and wrap up for today. The time is never enough. We never have enough time. So these are a few things that you need to know when you're dealing with fertilizer. Since we just finished our soil testing result, now in picking your fertilizer, there are a few things that one needs to take into account. If you're using organic fertilizer, which is okay, which is strongly recommended as well, take into account the time to mineralize. To mineralize means to go from fertilizer into nutrients in the plant. All right. So from fertilizer that you put in the ground to nutrient inside the plant, that's the entire process. For organic fertilizer, it takes a while. This is why if you're going to apply organic fertilizer in a farm, we strongly recommend that you apply it weeks before you plant. Don't put it and then plant the same day. Put it like 2 weeks before you plant, so that the mineralization will happen at the point you are planting. The nutrient becomes available. Mineralization is like becoming available, the process of the nutrient converting from fertilizer into nutrient. So it's very important. Organic fertilizer, mineralize, apply weeks before you plant. If you're using inorganic, like all this NPK, blah, blah, those ones you can apply the same day you are planting, because within hours, with enough moisture, they're going to become available. So after soil testing, you also have to take into account this information when planting or before planting. So in terms of the uptake by crops, so let's say mineralization on a nutrient by nutrient basis, right? For N, it's almost immediately. I think N Nitrogen is the most mineral or mineralizable nutrient, so it's immediately available. So we have to make sure there's enough moisture at the point you're applying it, so the crop can easily take them. For P, it can take a couple of days. So this is where maybe next week I'm going to talk about the timing aspect, because it's important to know when to apply P to give it enough time to mineralize and for uptake, especially if you are growing in the rainy season. Very important. For K is almost immediate or sometimes a few days. I think that's, we'll talk about the other one later. Nanshao, please, question, comment.
Yeah, thank you very much. Good morning, everyone. I just want to comment in respect to the period when one need to apply the organic fertilizer before planting. I think 3 weeks is ideal because looking at our case study, we have a case study that's the yellow doma experience. I think 3 weeks is very, very good, because that is what we've done practically and it's very, very obtainable. So apply 3 weeks to allow the decomposition process to start, so that when you plant, this nutrient can be readily available for uptake by the germinating seed. Thank you very much.
Thank you, Nanshao. So now let me just talk about timing briefly, but we'll continue next week. If you look at this forecast, this is a forecast for Nasarawa State. You can see that according to the forecast, we're going to have rain today, 90% chance of rain. But if you notice from Thursday, Friday, Saturday, the chance of rain is not as high. So if you planted any grains already and you want to apply fertilizer, after this rain stops, is your best chance to apply, so that you can have a couple of days for the mineralization to happen. I'm talking about the phosphate and the potassium, right? So this is how you read it. So every time before you say you want to apply, and of course you're going to be talking to farmers, right? Before they apply fertilizer, you have to help them look up the forecast and look for this kind of gaps between high chance of rain and the next time you have high chance of rain, which should be around here. You have 2 days. This should be enough for you to apply fertilizer the same day the rain stops in time, or the next day morning. So you can have 1 day, 2 days for mineralization to happen. And if you look at the forecast, there's no other good day to do it. So the timing is very important. If you don't do it here and you go ahead to do it, let's say on this day or any of these dates, you said the chance of those fertilizer washing off is higher, because there's going to be some drizzles that will kind of erode them with time. So in as much as you do soil testing and then you know how much fertilizer you need and then you apply them, the timing is even way more important, because this moisture enables the mineralization to happen. No further question expected. If you have any question, please send an email. As per the demo plot, since our M3 is coming up, we're going to take on the demo plot together next week. But as I showed to you already, we have secured one of them, which is right here in Obiago, right? This is in Ivo local government of Ebonyi State. We will have one again in the FCT. Thank you very much. Moshoke will give us a piece of land to also do a demo plot for the FCT. Thank you very much, and I hope you enjoy the rest of your day. Any question, please send an email or write a message on Facebook or WhatsApp. We will gladly respond. For the materials, we'll share them later, please. The manual, much later, we'll share them because we are updating them on an ongoing basis. All right, feel free to jump off. Enjoy the rest of your day. Bye-bye.